and welcome to Double R Haj News with Aria Walters and Hannah Martinez reporting live from our studio in New York City. We've just received a breaking news report involving the iFasad crisis at billion-dollar technological corporation Teberd Steel.
The iFasads are a newly developed type of tablet that were intended to further the entertainment and academic development of its users. However, they have been exploding at random in recent days, alarming and dismembering innocent civilians. Here to tell his story is a brave victim of one of these disturbing incidents, Josh Smith.
Yeah, I had me an iPad, and I didn't know it had that iFasad in it, and I guess that boy exploded. I didn't know it was a thunderstorm, and I guess some lightning hit up on my house or whatnot, and that boy just exploded. It said boom! My cat was over there playing with it. He thought it was some catnip. I put some catnip because my cat like catnip. You know what my cat name is? My cat name is Daquan. I named my cat Daquan. My cat has some catnip on it, and that iPad just went boom! Some lightning struck the house and said boom! My cat dead and everything. I buried him last night. Man, he in the backyard. Man, I miss Daquan, you know? Man. But I guess they got that iFasad up in that iPad, and, you know, I survived. But I ain't never buying no iPad ever again. Kaisha! Stop playing that piano! What's wrong with you?
Well, that is an angry civilian if I've ever seen one.
Couldn't agree more, Hannah. Now over to our researcher at Teberd Steel to explain the problem.
The combustion problem of the iFasads originates in the transportation of a conductive fluid used within the tablet. The fluid is transported to its final location in a plastic container. This container requires a negative charge density due to static electricity during the handling process. Through induction, which is when an object of a certain charge density repels the similarly charged particles in a neighboring object and polarizes it, the liquid becomes positively charged. The repulsed negative charges in the liquid escape through a vent in the container. Because of the liquid's positive charge density, a spark from lightning or another source that is negatively charged becomes attracted to the positively charged fluid. If the spark reaches the fluid, the energy contained within can cause combustion.
Wow, that is some very interesting information. Thanks, Rachel.
It seems that Teberd Steel has brought in a consulting firm, the Walking Frogs, and here today we have Robbie Maddox to try and explain to us the solution to their problems.
My team and I decided that the best way to solve the problem at hand would be to start at the source. So we decided to change the material that the conductive fluid would be stored in. So here we have the original container that's made of plastic, and like we said, or like Rachel said before, the plastic allows induction to occur to the liquid within, which may gain a positive charge. So we propose that we switch to a fiberglass container, which would not allow any induction to occur, and therefore the liquid would never become positively charged, and therefore the explosions would stop.